Okay, shall we start now, Chetan sir?
We are live on YouTube now.
Okay, okay. Okay, so good morning, everyone. On behalf of Indian Association of Physics Teachers, Regional Council 7, Sir PT Sarvajanik College of Science, Surat, and Association of Applied Baroda, I welcome one and all to this one-day webinar organized on the auspicious occasion of 143rd birth anniversary of Albert Einstein and on the PAI Day. Okay, as a member of IAPT as well as Executive Council member of APDA, I, Kavil Mehta, will be your host for this first session. On this special occasion, this is our first event as a alumni association, so it is very special for us members of applied physics department. So I congratulate one and all from the applied physics department and members of APDA. So I would also like to say that thank you to Professor Vinod Kumar, HOD of SPU and President RC7, Dr. Pruthul Desai, Principal of PT Science College, Secretary of RC7, and Dr. Chetan Limbachia, HOD of Applied Physics Department MSU and National Executive Committee member of IAPT, for organizing this amazing webinar. During the course of this webinar, I request everyone to mute yourself, and if any questions are there, please use the raise hand facility in the Zoom, and people who have joined us on YouTube can write their questions in the comment. Now, I would like to invite Professor PC Vinod Kumar to confer the presidential welcome. Professor Vinod Kumar, sir, please. Professor Vinod Kumar, can you hear us, sir? Hello. I think so. Vinod sir is having some difficulties.
I was unable to get.
Hello, Kavil. Kavil. Hello.
Okay. I'm
Yes, sir. Now
So Vinod
hear.
Kumar sir is with me. He will be addressing from my login, right?
Sure,
because
sir.
there is some issue. Okay.
Yes, sir. Yes.
Hello.
Yes, sir.
Yeah. Good morning to all.
Good morning, sir.
Start my video. It's all fine. You can hear my voice.
Yes, sir. Now you are audible and
Okay.
clearly visible.
Okay, fine. So first of all, good morning to all. And special thanks to MS University Applied Physics Department for participating in collaboration with RC07 for this program containing two very important lectures, particularly on this day when we celebrate the International Pi Day as well as the Albert Einstein's birthday. It's a pleasure for all the RC members of this region to collaborate with this program, and we have today very eminent speakers. One who will be speaking on the importance of pi and various historical aspects of pi. Professor Pramendra Singh, I welcome him to this program, and I hope he as well as our participants will enjoy his speech on the importance of pi. The second lecture is also very important. That will be at the later stage of today, and that will be on about Einstein, his legacy, and so on. So by Professor Ajay Bhatter. So I welcome both of them for this very important lecture series, and my congratulations to the Applied Physics Department on launching of their first alumni association meet. With this brief introduction, I welcome the speaker for this event, Professor Pramendra Singh.
Thank you so much, sir, for your words and blessings, and also for your blessings to our Alumni Association. Now, I would like to invite Professor Arun Pratap, sir, who is ex-Dean of Faculty of Technology and Engineering, MSU, and ex-President of RC7, to introduce our first speaker of the series, Professor Pramendra Rajan Singh. Arun Pratap, sir.
Ranjan Singh. Yeah. Okay. Thank you, Kavin. It's a pleasure to welcome Dr. Pramendra Ranjan Singh, the principal of Narayan College. As such, he is a student of physics and a physicist. But I have seen he's keenly interested in the developments in mathematics also, and I have observed one lecture by him in the Inspire Science Camp organized by him only, perhaps on infinite series. And I found in him a very keen person, keen to know the developments in mathematics or the allied subjects which are useful in physics, as useful as anything. As regards his introduction, as he told recently, today itself, that he has done his PhD from IIT Delhi under Professor B.B. Tripathi, and then he was group leader of 3 international Olympiad teams, 2 Vietnam, Mexico, and Croatia. He has also led 3 times. He was the group leader of the Asian Olympiad 3 times outside India, and he is a motivator, and I know him actually. हम उनकी मैथमेटिक्स की जो उनकी प्रतिभा है उसके व्यक्तिगत रूप से कायल हैं, इसलिए हमने उनसे ये अनुरोध किया कि बहुत सारे एब्स्ट्रैक्ट सब्जेक्ट्स पर जिस पर कि शायद बोलना और सुनना बहुत आसान नहीं होता, कठिन होता है, उस पर वो एक्सटेम्पोर बोलते हुए हमने उनको देखा है। और मैं उम्मीद करता हूं कि आज अपने वो सारगर्भित भाषण से आप सबको लाभान्वित करेंगे और कुछ ना कुछ हमारे अंदर स्पार्क क्रिएट करेंगे, जिससे कि हम even though we retire, we will keep on learning something new. At least I am personally keen to that. And with these words and with the kind of energy he produces when he gives lecture, it's a pleasure to invite Professor Pramendra Ranjan Singh for this first lecture on Pi on the auspicious occasion of Pi Day. Thank you.
Thank you. Am I audible? everyone?
Yes, sir. You are.
Thank you. May I start my lecture?
Yes, sir.
Okay. Thank you. Thank you, Professor Arun Pratap ji. First of all, good morning, everyone, including my Guru and Professor Ajay Ghatak sir. I am very much thankful to IAPT RC7 and Sir PT Sarvajanik College of Science, Surat and Applied Physics Department Alumni Association. You people have invited this very lecture series today and given me opportunity to say something about the PAI. And as Professor Arun Pratap has told you, I'm a man of physics, I'm a physicist, but I'm very much interested in mathematics, and rather I always like to share my knowledge with my students and colleagues in the field of mathematics. So first of all, thank you very much, Professor P.C. Vinod Kumar ji, who is the president of IAPT RC07, Head Department of Physics, Sardar Patel University, Ballabh, Vidyanagar. Thank you, Professor Arun Pratap ji, ex-president IAPT RC07, Department of Applied Physics, MS University, Baroda. Thank you, Professor Kirit Lal, Department of Physics. Thank you, everyone. Thank you, all participants, and welcome. Kavil Mehta, and because I am associated with the IAPT RC19 of Bihar region, and from the Bihar region, RC19 IAPT, मैं आप सबों को प्रणाम कर रहा हूँ, सादर नमन है और स्वागत है RC19 के सारे सदस्यों. Today is Pi Day as well as birth anniversary of great physicist, great mathematician Albert Einstein, and really it's difficult to make our mathematical things or mathematics easy for its perceptions, its requirement, its uses. But whenever we are introducing the constant like your pi, Planck's constant, universal gravitational constants, Boltzmann constant, Avogadro number, those numbers are the universal constant, and pi is the constant. From the ancient India, rather, I think so, more than thousands, more than millions have already tried to understand what's the exact value of the pi and what is the significance of the pi, from where it is coming, and how it is very much important for not only for the mathematician, rather for the physicist, for the chemist, and right now pi is used everywhere in the all branch of mathematics, physics, social sciences, statistics, everywhere. So basically, earlier pi was this is the Greek word and Greek alphabet, rather pi, delta, gamma, etc. So pi is defined as the ratio of the circumference of a circle and its diameter, C upon D. So for the length, simply it's the introductory part of the pi. If pi is a constant, if we are going to draw any circle, whatever its circumference, whenever it is divided by its diameter, we are getting a constant, and that very constant is the pi. Now, for getting the values of the pi, there is a history. I mean, as I told you, from the last 5,000 years, we are trying our best to find out values of the pi up to maximum digits, and how it is your applicable in the different branch of the physics, in different branch of the mathematics. Rather, right now, in my lecture later on, I will simply give you the all branches and describe how pi is utilized in the different branch of the physics, in mathematics, and in other branch of the science. So now, approximately, whenever we are asked, simply giving the concept of the pi in the school for the school boy, we are saying this is approximately equal to 22/7. In school, for the school boys, we are introducing the pi as a unit of angle. Unit of angle is the radian, and we are saying that when we are going to draw when going to define our radian, so we are going to simply give a conversion factor between your radian and the degree. Pi radian equal to 180 degree, and 1 degree. Am I audible? Am I audible to everyone?
Yes, sir.
Yes, you are.
Okay, thank you. So there is a conversion factor between your radian and the degree, and 1 degree equal to pi upon 180 radian. For school wise, we are introducing this one, and for getting the values, how much the value of the pi. So in our, when we got the introductions of the pi in class 7th, 8th, 9th, in field of your Euclidean geometry, in field of the trigonometry, in field of the somewhere algebra, later on, intermediate level, in graduation level, the introduction of the pi in different fields of the physics, in different chapters of the physics, we got the pi value. Later on, for the mathematics of the topology and the differential geometry and the other parts of the applied mathematics, we are using the value of the pi. So it is very interesting how we are, why we are much more interested to know the value. It is very much important for us, because if it is not important, and if it is not, or it is not rather only important, we can say it is very much interesting. How pi governs the several formula, how pi give us the several ideas, new ideas to do express our new formulas, to get our new horizon and the new vision of the any new formulas, lemmas, and corollaries, etc. So I'm giving you some history from where the pi has started. As we know, firstly, if we are going to take the pi equal to 22/7, why this 14th March is celebrated as Pi Day? One of my students today in the college asked, "Sir, Pi Day." So this is we have to know why the 14th March is the Pi Day. We are celebrating as a Pi Day. So basically, the first 3 digits of the pi, that is your 3.14. So we celebrate this 14th March as a Pi Day. This is the, after decimal, there are 2 digits, 1/4, that is your 14 we have taken, and the month of the third month of the year. So 14th March is celebrated as the Pi Day on the value of the pi up to the 3 digits, that is your 3.14. This is the one way in which we simply say that why we are celebrating our Pi Day on 14th March. Now, without taking much more time in the introductions and these all things, I'm going to directly on the utility of the pi, on how it is important in your different parts. Right now, we can say pi in your early days, Archimedes had tried to find out the value of the pi first of all. So Archimedes, it is also referred as the Archimedes constant. Pi is also referred as the Archimedes constant. And the interesting part about the pi is it is ever ending constant. it is not going to terminate somewhere. It is your irrational and transcendental. Be careful. There is not any repetition of the any digits. Somewhere in some places, it may be possible a few digits are going to be repeat four times, 5 times, 6 times, but there is not a recurring. There is not any particular repetitions of the digits in a particular pattern. There is not any fixed pattern in the repetitions of the digits in value of the pi. So this is very important and very interesting how pi varies. And later on in my lecture, I will simply give you the several series, infinite series, and the other iterations, formulas, and the model, how we are getting the pi and how several mathematicians got the values of the pi up to the several digits. So in that very part, we will simply see how the value of pi is important. It is a decimal digits appear to be randomly distributed and are conjectured to satisfy a specific kind of a statistical randomness. It is very important. As I told you, basically, if we are going to search any particular pattern of the digits in the value of the pi, after 4, if it is or 5 is coming at the 56 positions of the decimal, what will be at the 76? We can simply find out any correlations between them according as the positions of the different digits. We will not find out. We are not getting any correlations among them and any pattern of the appearance of the digits in the value of the pi. This is the important point. It is transcendental. It is not the root of any polynomial. This is not any root of any polynomial with rational coefficient. This is the important point. This is a transcendental one. So this is not any root of the polynomial. We cannot say like this any polynomial, this very polynomial, the roots of this very polynomial particular root is going to be simply expressed in terms of the pi. So this is the important part. Two important things is important regarding pi is important. First one, it is irrational, and the second one is transcendental. As we simply see the history of how we got the value of the pi and the definition on the basis of the Euclidean geometry, it is the ratio of the circumference and the diameter of the circle. Ancient civilization, including the Egyptian and the Babylonian, required fairly accurate approximation of the pi for practical computation. As I told you earlier, Archimedes has tried himself, Greek mathematician, has tried himself a lot to find out the value of pi, and he found out it, no doubt about this, up to a particular digits, 3 to 4 digits. In the 15th century AD, Chinese mathematician approximated pi to 7 digits. Why? Very important for us. The Indian mathematician find out to get the value of the pi up to the 5 to 6 digits first time, and this was done by the Madhava, and which is known as Madhava-Leibniz series, and this was simply discovered by the Kerala School of the Astronomy and Mathematics. It is documented in your Yukti Bhasha, written around 1513. So Madhava found out the value of the pi up to the 6 digits accurately. He was astronomer and the mathematician of the Kerala School of Astronomy. Or in year of the 1530, which is your simply documented in the particular book, Yukti Bhasha, find out the value of the pi up to the 6 digits. Now it is what's the value of the pi up to what level is the accurate value is there up to the decimal level? With the help of the supercomputer, trillion digits are there in the values of the pi, and still we are simply waiting because it is not going to terminate. Its value is not going to be terminate. So more accuracy, more precision may be get later on in the value of the pi. So now, simply because definition is coming from pi is coming from the circle. So I am giving you idea. If there is any circle and its radius is r and its circumference is your 2 pi r. So this pi equal to c upon d. So that is equal to 2 pi r upon 2r. This is the definition. Is it visible to everyone?
Yes.
Now, interesting part is there. If we are going to discuss the two-dimensional coordinate geometry, so in that very case, this is x square plus y square equal to r square is the equation of the circle having the radius r. Now, if this is your radius r, if we are going to consider a circle having the radius unity, so in that very case, our equation of the circle is x square plus y square is equal to 1. This is the equation of the circle having the radius unity. So we can say that this is root under this y equal to 1 minus x square. So area in terms of your language of the calculus may be written as y dx equal to integration over y dx. So this is equal to, instead of the y, if we put 1 minus x square dx, and value of x varies from minus 1 to plus 1, we will get the area of the circle, and that should be equal to pi into r square, and because r is the 1, so we will get the value of the pi in terms of this very integration value. So we can say that this pi equal to integration from minus 1 to plus 1 minus x square dx. And easily a student of intermediate or graduation level will get the value of this pi by the substituting x is equal to sine theta or cosine theta, whatever he wants to simply do. So he will get the value of this integral part is equal to the pi. So it is very easy to find out the pi with the help of this very analytical geometry concept, because we defined our value of the pi in terms of the circle. So in early life, how the mathematician and other person were able to find out the value of up to the more digits accuracy. This is the very important point. So if it is the simple area of the circle is the important or the value of the pi, how we can simply find out the area by the computations of the geometry. So we develop the polygon area to getting the polygon area in terms of the inequality. As for example, if we are going to take a pentagonal shape, in that very case, circumcircle and incircle. If we are going to take the circumcircle and the incircle, we can find out the area of the circle by getting the circumcircle and the incircle of the polygon, and in that very limit there is your area of the circle. So by simply adding more sides, hexagonal and more sides, and make a polygon of the sides 10 raised to the power 10, 10 raised to the power 20, we were tried our best to find out the value of the pi with the accuracy up to the more. That was our way, earlier way, an ancient way to find out the value of the pi. Now, I'm giving you later on if geometry, as I told you, by getting the values of the different geometrical shape of the polygon and getting the area of the polygon, we can find out the value of the pi. As I simply described you, if I am going to consider a hexagon and any circle, here, in circle and circumference, this one. So by getting this very area of this hexagonal shape, this area, this is very much approximate to the area of this very circle, or this very circle, by increasing the number of sides. If we are going to increase the number of sides, n is equal to 6, 7, and so on, up to 10 to the power 20 or 10 to the power 40, we will get almost very much accurate values of the pi by getting the area of the polygon. Polygon having the very large number of sides. So this was the earlier effort, on the basis of which we tried our best to find out the value of the pi up to very much accurate and in terms of the more detail. One interesting point is this, because this is the constant, which is very much interesting and very useful in the all branch of the science, in physics, in mathematics. As we mathematician, we are discussing the several things. If we are going to simply teach the students the electrostats, or we are going to teach them the Fourier transform, or we are going to teach them the quantum mechanics, and if we are going to teach them the Heisenberg uncertainty principle, everywhere, if we are going to simply give them the concept of the complex analysis, everywhere we are using somewhere the value of the pi. We are going to normalize the function. We are going to represent our electrostatics. As for example, we are going to discuss the Gaussian theorem. We are saying that the total normal electric induction is equal to, in an integral system, the 4 pi q, where q is the enclosed charge. Always students are asking, sir, why you are using the 4 pi constant? Why not it is your something else? 4 is the integer. Why you are using the particular integer 4? Why you are using this very constant pi? Why not the other constant? So when we are giving them the concept in three-dimensional manner, if we are going to represent how pi is your coming, if we are going to take the area of the circle, which is your two-dimensional geometry, that is your pi r square. If we are going to consider the surface area of the sphere, that is your 4 pi r square. If we are going to consider the volume of the sphere, that is your 4 by 3 pi r cube. If we are going to represent the area of the ellipse, that is your pi AB, where A and B's are the semi-major and semi-minor axis length. So area of the ellipse, area of the parabola, area of the any conic sections, area of the circle, and volume of the circle, surface area of the circle. In that very case, everywhere using the pi. So if any event is going to happen somewhere, and if its propagations radially outward everywhere, so in that very case, its impact and its effect will be the spherical in our surroundings. If it is, so we have to find out the how up to in terms of the area. So we are interested to find out the area of the sphere. And if area of the sphere we are considering, so in that very case, there is your term 4 pi there. So that is your 4 pi r square is the surface area of the sphere. So if it is the surface area of the sphere, and as for example, if we are interested to find out the power or intensity of a light, if intensity of is the light we are interested to find out somewhere, if there of any the light, in that very case, whatever the power of the source, that power per unit area somewhere is the intensity of that very source light. So if it is, So we have to divide our power by the surface area of the sphere. And this is your 4 pi r square. And that's why intensity varies as inverse square law 1 by r square. Its intensity varies with the distance. As well as there is a constant, particular constant, which is 4 pi is there in that very term. So pi is not appeared at one place, rather, according to me and according as the mathematician, pi is associated with the all correlations of the nature, all correlation given by the nature for the explanations of our natural happiness or for the explanation of our natural event. So that's the important. Now I am going to give the second attempt. How the earlier were to find out the value of the pi, apart from the Euclidean geometry and apart from the getting the area of the polygon. So listen, my first part was this. Earlier we tried our best to find out value of the pi with accuracy, with precision, up to the maximum number of the digits. That method was to find out area of the polygon having the much more size. And a lot of people had tried in worldwide to get it and do it.
This thing. Now, as the Persian astronomer Jamshid al-Kashi produced a sexagesimal digits, roughly the equivalent of the 16 digits in 1424, using a polygon with the 3 into 2 to the power 10 to the power 28 sides. So many mathematicians has tried. The French mathematician Francis Viette in 1579 achieved the 9 digits with the polygon of the 3 into 10 to the power 7 sides. Dutch mathematician Rudolf van reached 20 digits. That is why pi was called Rudolphian number in Germany until the early 20th century. Dutch scientist Willebrord Senius reached 34 digits in 1621, and Austrian astronomer Christopher Greenberg arrived at 38 digits in 1630 using 10 to the power 40 sides of the polygon. So we have seen so many mathematicians in our era of the from 1500 to 1700 century tried their best to simply find out the value of the pi up to the maximum number of the digits with the accuracy, and they tried on the basis of the find out the area of the polygon having the sides on the basis of the computation having the side 10 to the power 40. Now, in the second attempt, later on, we find out it is very difficult in computations. Rather, that very computations and calculation was taking a lot of time to find out the area. It was not very easy task to find out the area of the having a polygon having the side 10 to the power 40. It is a very tedious task, and it was at that time too. So if we are not going to use any our computers and the supercomputers and the calculator in that very case, it was rather very tedious task at that time to find out the area of the polygon having the side 10 to the power 40 like this. So later on, the mathematician and most of the physicists and other persons, those were interested in value of the pi, they tried themselves to find out the value of the pi on the basis of the infinite series. And this is very interesting one. How several mathematicians put the several infinite series on the basis of, first of all, continued fractions. Let me introduce a fraction. This is very interesting. See, this is your 3 up plus 1 upon 7 plus 1 upon 15 plus 1 upon 1 plus 1 upon 192 plus 1 upon 1 plus 1 upon 1 plus 1 plus so on up to infinity. Let me say you, if we are going to see this very continuum fractions, this is pi equal to 3 plus 1 by 7 plus 1 upon 15 plus 1 upon 1 plus 1 upon 192 plus so on. This is the very interesting one. See, if we are going to consider this very fraction up to only second term, in that very case, this is equal to 3 plus 1 upon 7, and that is equal to 22 by 7. So most of the students of the school and the colleges using the value of the pi, that you're approximately 22 by 7. Be careful. Most of the teachers are saying the value of the pi is equal to 22 by 7. 22/7. याद कर जाओ कि pi का value 22/7 होता है. But this is approximate value. I am saying you. Still we are unable to find out the value of the exact value of the pi. It is not going to terminate. So this is very important. Still so many persons are trying themselves to find out the value of the pi in the terms of the more digits. So up to the simply, if we are ignoring the rest of the term here, then we are getting the value. This is your 22 by 7. So what will be the next one? This will be the very interesting. Pi, if we are going to consider the next term up to this one. So this is your pi equal to 3 plus 1 upon 7 plus 1 upon 15. So this is very much interesting. So we can see this is 3 plus 1 upon 105 plus 1 upon 15. So this is 3 plus 15 upon 106. So this is 318 plus 15 divided by 106. So we can see here this is equal to 3 pi equal to 333 upon 106. This is also value of the pi. If we are going to consider this third term in our continuum fractions. So this value of the pi is this one. This value of pi is this one. And similarly, if we are in this very continuum fractions, if we are consider the fourth term, fifth term, sixth term, and so on, we will get so many accurate values with the precision of the value of the pi. This is one of the continuum fractions which gives us the value of the pi. This is the second type of the attempt to find out the value of the pi in terms of our fraction. Now, similarly, if we have so many fractions and so many infinite series, those series and those fractions are able to give us the value of pi. Similarly, this is one of the also very interesting fraction which gives us the value of the pi. This pi equal to 4 upon 1 plus 1 square upon 2 plus 3 square upon 2 plus 5 square upon 2 plus 7 square upon 2 plus 9 square. So this is very easy to express this upon so on up to infinity. This is infinite continuum fractions. This is pi equal to 4 divided upon 1 plus 1 square upon 2 plus 3 square divided by 2 plus 5 square by 2 plus 7 square divided by 2 plus 9 and up to so on. This is also going to give us the value of the pi. But interestingly, if we are going to simply neglect these all terms, we are getting the value of the pi is equal to 4. That is your far, we know that up to the 3 digits, the value of the pi is your 3.14. So this is the very, far ahead to the real value of the pi. So this is not considerable to simply ignoring these terms here. Now, if we are going to consider the second term, so this is pi equal to 4 upon 1 plus 1 square by 2 if we are going to ignoring these all terms, so in that very case, this is your 2, this is your 3 by 2, this is your 8 by 3. 8 by 3. Now, this value is less than 3. So this is not acceptable. So then we have to consider more terms. Then we are going to be simply almost this very fraction is going to converge at the nearby value of the pi. Also, this is your expressed as 3 plus 1 square divided by 6 plus 3 square, 6 plus 5 square plus 6 plus 7 square, 6 plus 9 square plus so on. So one can simply find out a pattern of this very value. This is your all odd integers 1, 3, 5, 7, 9, 11, 13 and so on. Also, by taking here up to this, if we are going to simply ignore these all terms, we are getting the value of the 3, which is your less than the value of the 3.14. If we are going to consider the second term, this is your 1 upon 6. So this is your 3, if it is your 6, so this value is your 3.18. This is your slightly more than 3.14. If we are going to consider the third term, so it is your slightly less than 3.18. It is near to the 3.14. So if we are going to consider the other terms, more terms, in that very case, we are almost going to find out the value of the pi and converging at the very nearest value of the pi, that is equal to 3.14. Now, the question is this, one can ask, right now, up to what digit we have accurate and precise value of the pi. Now, in terms of the integers, it is 3. Fraction 22 by 7, 333 by 106, 355 by 113, 15163 divided by 166004. In terms of the digits, I'm telling you, very interesting for any student. One can find out these all data in your so many books and so many places in Wikipedias and the Google. These all values are given there. So in terms of the digits, right now up to the 50 decimal digits, this is your 3.15926533589793223837533837169399375110. मतलब अगर हमसे कोई पूछता है कि पाई का वैल्यू 50 डिजिट तक कम से कम सही बोलो, तो ये वो 50 डिजिट है जहां हम कह सकते हैं कि पाई की वैल्यू अप टू द 50 डिजिट्स ये एक्यूरेट वैल्यू है. नाउ द इन टर्म्स ऑफ द बाइनरी बेस 2 में अगर बाइनरी टर्म्स में हम लोग कहें तो दिस योर 11 decimal 0011 1001 00001. This is your simple binary conversions of the above given values. So this one. अब now interesting part is there. In terms of your exponential terms, we can simply write down this relation also gives us the value of the pi. From where we are getting these all values? We know that this is your Euler's equations. So e raised to the power ix is equal to cos x plus I sin x. Instead of the x, if we put the pi, this is the cos pi plus I sin pi. Cos pi. So if we are going to put I pi, we will get the value of the cos pi as I sin pi. We know that sin pi value is 0, cos pi value is -1. So this is your e raised to the power I pi equal to -1, or one can say e I pi plus 1 equal to 0. So this is another way to simply express our value of pi. Now, so these are the ways, earlier ways, rather ancient way till the 18th century, till the 19th century to find out the value of pi. Most of the students and rather the teacher are also interested to simply know the history of the pi from here. So first time when we got the value of the pi, what was it important and why we are so much interested earlier to simply do it, etc. So just I make a short history, brief history on this. Basically, it was the value of the pi find out in Babylon on a clay tablet. हमें जो बेबीलोन में खुदाई में एक क्ले टैबलेट मिला जो लगभग 1900 से 1600 जो बीसी था उस समय, वहां एक पाई की वैल्यू मिली हमें, and that was written value was 25/8. That is approximately, that is equal to, this is your terminating term and this is your 3.125. It is your terminated up to the 4 digits. So first time we got the value of the pi somewhere in the written form in the Babylon. In Egypt, the Rehan papyrus dated around 1650 BC. That is your pi as, see, that pi value we got, that is your 16/9, the whole square. And this is approximately 3.16. In history, this was the second term when we introduced this one. Third one, the astronomical calculations in our Indian effort behind the pi to get in the pi. Indian mathematician rather tried, Aryabhat has tried to find out it, Madhavan has tried, Sapat Burma has tried to simply get it. In the 4th century BC, fractional value of the pi in India, this is the proudful thing for us. So Indians find out the value of the pi. Earlier, that very value they have given 339/108. That is approximately up to 3 digits, 1.139. So see, we know that pi up to the 3 digits is a 3.14. So in comparison of this very number is very near to the value of the pi. So the Indian effort before the Christ be tried by the Indian mathematician and the astronomer, and they find out the value of the pi, that is 339/108, which is approximately 3.139. So this is also very much important, interesting. Now I'm giving you how the several Europeans and the Chinese and the Indian collectively tried themselves to find out the value of the pi in form of the different mathematical forms. So these are a few I'm giving you. This is your value of the pi. This is given by the French mathematician Francois Viette in the 1563, while John Wallis in the 1655 has given the value of the pi with the terms of this in these terms. This is given by your French mathematician. This is given by the John Wallis in the 1651. Both are the French mathematician. They have given the value of the pi in these terms. So almost all European mathematician, Chinese mathematician, Indian mathematician, and at the ancient time, at the Babylon, at the Greek, so many persons tried to find out the value of the pi. Now, after 16th century and the 17th century, for getting the value of the pi, after simply introductions of the Gregory series and to get the expansions of the sin x, cos x, tan x, with the help of the calculus, with the help of the trigonometry, we found a very, very, important series, that is your Gregory's Leibniz series. This is very important series. And see, almost all mathematicians and all physicists know this very expansion, the expansion of tan inverse x. And this expansion is x minus x cubed by 3 plus x to the power raised to the power 5 upon 5 minus x raised to the power 7 upon 7 plus x raised to the power 9 upon 9 minus so on up to infinity. This is infinite. This is the expansion. This expansion is that you are known as Garagari and Leibniz series. Now, this is very interesting expansion, which gives us the value of the pi, which gives us the value of the pi. If we are going to consider the first point, second point, third point, and so on, we will get the value of the pi in terms of this one by simply doing this. If we put x is equal to 1, then this is your tan inverse 1 equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus 1 by 9 minus so on. And we know that tan inverse 1 is pi by 4 radian or 45 degree. So this is 1 minus 1 by 3 and plus 1 by 5 minus 1 by 7 plus 1 by 9 minus so on. So value of the pi is 4 minus 4 by 3 plus 4 by 5 minus 4 by 7 plus 4 by 9 minus so on up to so on. So interestingly, if we simply see first level, if we are going to ignore the rest of the part except the first term, this pi value is equal to the 4. If we are going to take the consider the first and the second term and the rest part we are going to ignore it, it is your 4 minus 4 by 3. So this is your 12 minus 4 by 3, this is your 8 by 3. If we are going to consider these three terms, so as we are going to consider up to the very large terms, we are going to find out the value of the pi up to very accurate value. So this value, Gargari's Leibniz series, gives us the very much accurate value of the pi. Now, so we can say that हम लोग कह सकते हैं कि हम अपने पाई के डेवलपमेंट का और पाई के पूरे लाइफ का मतलब एंशिएंट टाइम से लेकर के अभी तक 3 पार्ट में बांट सकते हैं. The ancient mathematician and astronomer, whatever they have tried to find out the value of the pi, up to the 12th century, 13th century, or 14th century. Later on, after 14th century to 19th century, so many mathematicians, European mathematicians, Chinese mathematicians, and other mathematicians have tried themselves to simply find out the value of the pi with accuracy and precision up to the very large number of the digits. So their basis to find out the values of the pi, firstly we discussed on the basis of the areas of the polygon by making the number of increasing the number of sides much more like this. Later on, we tried our best on the basis of the making the continuum series and getting the Gargari's series, Leibniz series, and the several other fractions, and to find out the value of the pi. Right now, what's the 2D's technique and what we are going to do it nowadays? That's very much important. So, what's the modern quest for the more digits? This is the important part. This is the third and last part. We can simply discuss about the pi. That is after the second half of the 20th century. We can say after introductions of the computer, after introductions of the computations, iterations, etc. So, year-wise, we can say computer era and iterative algorithm era when has started. So up to the 7480 digits, लगभग 7480 digits तक हम लोगों ने वैल्यू जो प्राप्त किया था पाई का एक्यूरेट वैल्यू वो 1957 तक किया, 10,000 डिजिट तक 1958 तक किया, 1 लाख डिजिट तक 1961 तक पहुंच गया, 1 मिलियन डिजिट 1973 में पहुंच गया। मतलब कि हमारी जैसे ही कंप्यूटर और इटरेटिव एल्गोरिथम्स हमारी इंट्रोड्यूस्ड हो गई तो हमारे तेजी से हमारी एक्यूरेट वैल्यूज ऑफ द पाई आप देख रहे हैं कि 1 मिलियन हमारी पहुंच गई 1973 में ही, जब हमारे पास कंप्यूटर का सपोर्ट आ गया, कंप्यूटेशंस में इटरेटिव मेथड्स आ गए। अभी आगे हम 2-3 और मेथड डिस्कस करेंगे जिससे हम लोग आज का वैल्यू ऑफ द पाई बहुत ही एक्यूरेटली हम लोग डिस्कस करते हैं। अब ये इटरेटिव मेथड एल्गोरिथम आने के बाद कंप्यूटर्स को भी काफी कन्वीनियंस हुआ। जो कंप्यूटर से वर्क कर रहे थे उसमें से एक बड़ा इंपॉर्टेंट इटरेटिव है मेथड्स है, दैट इज योर गॉस-लीजेंड्रे इटरेटिव एल्गोरिथम। तो गॉस-लीजेंड्रे इटरेटिव एल्गोरिथम में आपका जो है कि पाई is approximately equal to an plus bn the whole square divided by 4tn, where this an plus 1 equal to an plus bn divided by 2 and bn plus 1 barabar root under an plus bn. Student of the graduation level and the PG level easily can understand the iteration, how we are simply going to find out on the basis of the one term, simply we can find out the another term and the previous term value correlations, how the terms of a series or sequence is correlated, and how we can simply expand our series and the sequence on the basis of the iterated. So this is the one of the iteration method to find out the value of the pi, and Tn plus 1 is your Tn minus Pn, an minus an plus 1, the whole square. So with this very iterative formula, that is your Gauss-Legendre iterative algorithm, gives us the very, important mechanism to find out the value of the pi up to the very accurate value. Now, one of the great mathematician of the 20th century and genius, mathematical genius and wizard, everything we can say, wizard of the mathematics, and the Indian, be Indian, it is a matter of proud. The mathematician Ramanujam has also tried to find out the value of the pi in terms of the integral values, and Ramanujam formula for the find out the value of the pi is 1 upon pi is equal to 2 root 2 upon 9801 summation over k equal to 0 to infinity 4k factorial 1103 plus 263. He was the man of the digits, and that's why he has given the value of the pi in terms of the very much terms of the digit factorial k 396 raised to the power 4k. And this very relations, with the help of this very relation, Ramanujam obtained the value of the pi up to the very accuracy. Now, nowadays, we are using the Monte Carlo methods everywhere in field of the quantum mechanics, in field of the statistical mechanics, in field of the all applied things, to get on the basis of the random distribution and the randomness of the event, Monte Carlo method, and with the help of the Monte Carlo methods, evaluate the result of the multiple random trials can be used to create approximations of the pi. In this very method, we are simply multiplying the several probability, and on the basis of that, we are getting the value of the pi. We consider the Buffet needle and dropping it. This is the technique. The length of the needle L is dropped n times on the surface on which parallel lines are dropped n times on a surface on which parallel lines are drawn t units apart, and if x of those times comes to rest crossing a fine x is greater than 0, then one may approximate pi based on the counts. So if we simply consider this is the t, the parallel lines, these are the n lines, and we drop a needle, this is a Buffet needle. So we can simply find out the value of the pi on this very relation, that is your 2 and L, where L is the length of this very needle, 2 and L upon xt. So this is another method. Now, so these are the all different mathematicians have tried themselves to find on the basis of the iterations and the computational series, on the basis of the area, Euclidean geometry, with the help of the Euclidean geometry to simply do these all works. Now for we physicists, what we are doing? So in our eigenvalues problems, if we have any differential equation like this, so this is your lambda fx equal to 0. Like this f double prime x, we know that this is your d2 fx upon dx square. So this lambda is equal to minus. This is mu s square, the solution gives us this one. And this mu is equal to pi. So by getting this very differential equation stand, whatever we are getting the value here, eigenvalues lambda, in terms of this one, we can find out the value of the pi. This is another method. And this pi square is 0 to 1 modulus of fx, the whole square dx, is the less than or equal to 0 to 1 modulus of the f prime x, the whole square dx. This then inequality gives us the value of the pi. So in terms of the simply getting our eigenvalues problems, also we physicists, we can find out and evaluate the value of the pi, and the pi use of the pi is there as eigenvalues. Now in Fourier series, which we use frequently everywhere in physicists, this is so in Fourier series, in normalizations of this very series and in this very expansion for the conversions, this is your xi whenever expressed in terms of the x. So we can simply here use the pi, and the use of the pi in the Fourier series is very much frequent and very much useful now. Now, in our statistics and probability, we use of the pi is very much as your normalizations factor and the other things. So there is a Gaussian integrals. This is minus infinity to plus infinity e raised to the power minus x square dx. This is equal to root 1. If we take that, this is your fx is equal to e raised to the power minus x square, and we draw a graph here. This is fx versus x. So we will get this very graph. So now the area of this shaded region is equal to root pi. So after in your this very Gaussian integrals, if we are going to get the area of this very shaded region, we can find out the value of the root pi. So this is another way, simply do that. Because today is the birthday of great Albert Einstein. And who is rather Einstein is the inspiring person for all of us, not only for physics. He is the towering figure and Himalayan figure, rather he is the for the modern science and technology. Albert Einstein is the unparalleled scientist, and that's why in today without his contributions, because his contribution is everywhere, like Newton, in all branches of the science. So if we are going to end our lecture without giving him the respect, in his formula too, the pi is used, and that is very, very well known four-dimensional potential associated Einstein equations. So in Einstein's equations, R mu minus half R G mu plus lambda G mu equal to 8 pi capital G divided C raised to the power 4 phi mu. We physicists and we student of the physics, we know these all, terms, notations, values. This R mu is nothing, Ricci curvature tensor. This R is the scalar curvature, G mu is the metric tensor, and this is your cosmological constant, this is your universal gas constant, this is your velocity of light, and this is your well-known stress energy tensor. So in Einstein's relations, the pi is associated. And in our statistical mechanics, in all our distributions, because those all distributions are always in terms of the exponential terms, and exponentially we have seen that exponential terms are the later on correlated as the pi. How it is your simply correlated? With the help of the two more examples, we can give you the idea. So in our complex analysis problem, when we discuss up to the graduation level students, undergraduate students, we are using the causes and formula. So this is your, in a closed curve, if we are simply use x naught is the 0, and this very causes relations in a closed curve fx upon the x minus x naught is equal to 2 pi I. This is the value of the function at the 0 x. So here this is the value of the pi is appeared, and this is your very well-known formula for our in complex numbers. Now the last one I'm giving you, that is your gamma function. That is your gamma x equal to e to the power I gamma x upon x. This is your product summation n equal to 1 to infinity. So in this very relation, if we find out the gamma half, this is a very interesting value. This gamma half is the root part. So recall the things. This is nothing. This is the integration over e to the power I minus x squared dx. So minus infinity to plus infinity. So this gamma half is equal to root pi minus infinity to plus infinity e raised to the power minus x. This one. So now, before concluding this lecture of this very series, I want to simply conclude it briefly in 1-2 minutes. We have seen today in this lecture how pi is associated with our nature. It is this very constant is irrational and transcendental. And for getting this very constant values, we simply tried our best in the different phases. In ancient time, we tried to find out it and to obtain its value on the basis of knowing the area of the polygon. In the middle era, we simply made it the computational fractions and the several correlations and the series, particularly in finite series, to find out the value of the pi with accuracy and the precision up to high number of the digits. And in the right now, in present era, we are getting the value of the pi with the help of the iterative methods and the computation and with the help of the supercomputer. Right now, we have trillion digits value of the pi. Now, I am simply concluding this very lecture with this very comment. If we are going to discuss the such type of the constant regularly among the students and the teacher, and providing them the uses as well as their origin and uses and their characteristics, we can simply give them the brief ideas of the so many things in terms of this universal constant, these constants. So thank you very much to giving me the time. And again, I am wishing this IAPT RC 7 Gujarat and the PT Sarojini College of Science, and particularly Surat and the Applied Physics Department alumni. And I'm very happy today. Most of my teachers and the colleagues are in this very lecture. It may be possible that during my lecture, कुछ गलतियां हो गई हों या कोई चीजें ऐसी बातें हो गई हों जो आप लोगों को क्लियर नहीं हो पाई हो, तो हम लोग अपने क्वेश्चन आंसर सेशन में उसको क्लियर कर सकते हैं, या लेटर ऑन मैं अपनी ईमेल एड्रेस आपको मैं लिख दे रहा हूं, उस ईमेल एड्रेस पर भी आप हमें कांटेक्ट करके चीजों को क्लियर कर सकते हैं, और हम लोग कोशिश करेंगे कि इस तरह की चीजें हमारे यहाँ हो। और फिर अगली नई सीरीज में मैं आईएपीटी अपने RC 19 के तरफ से कोशिश करूंगा कि अगले किसी अच्छे इसी तरह के साइंटिफिक ऑर्गेनाइजेशंस में कोई भी हम लोग काम करें, तो हम सब लोग जुड़ के एक नई कांस्टेंट पर फिर हम लोग बात करें। सो दिस इज योर DR Pramendra 1966@gmail.com. So this is my email address. अगर कोई दिक्कत हो या कोई चीजें हो तो आप हमसे कर सकते हैं। थैंक यू एवरीवन।
Hello. Yes. Am I audible?
Yeah.
Okay. Thank you so much, Pramendra sir, for such a amazing lecture on pi. I mean, we got to know so much about how the pi was calculated to the very precision at the present. Now, I would like to open this session for questions. So if anybody has questions from our Zoom platform, please, they can write on in chat box, or they can even unmute themselves and ask the questions now. If anybody has any doubts in our YouTube live, they can write in the live chat box, and we will make sure that lecture is asked. I mean, Pramendra sir answers the question. Okay, so if there are no more questions, then I would like to meet Professor Kirit Lad from Sardar Patel University, and also my teacher in my Department of Applied Physics, to give the welcome speech. And sorry, the vote of thanks. Sorry. Yes,
Okay.
Kirit, sir.
Okay. Thank you, Kavil. Am I audible to you? Hello.
Yes.
Am I audible to you?
Audible, sir.
Yes, sir.
Yeah. Okay. So thank you, Kavil. So at the end of the lecture now, on behalf of the APADA, Association of Applied Physics Department, now it's my duty to give vote of thanks. So anyway, before that, we had a wonderful lecture from Professor Pramendra Singh on various aspects, technical as well as historical aspects of pi. So we know that as a physicist, pi has been such an integral part of our every day living with physics, I mean, we hardly ever notice the importance of pi, because it is everywhere in almost every formula. You take it uncertainty principle, you take Coulomb's law, right? You take atomic and molecular physics, Rydberg constant. Everywhere you will find pi appearing, but perhaps we will have not noticed what significance that pi has. So in some way or other, we are always associated with pi. So on this auspicious day of Pi Day, Professor Pramendra Singh delivered a wonderful lecture and enlightened us about various aspects. So we are thank you, sir, for devoting your precious time and also share the knowledge with us. So we are heartily thankful to you from IAPT as well as APDA. Then I have thanks for the IAPT office bearers, President Professor P.C. Vinod Kumar, Secretary Professor Puthul Desai, who made us part of this event, the Alumni Association of Applied Physics Department, and we could now launch our activities with this program. So we thank office bearer of IAPT RC7 for making us part of this program. Then I also thank Professor Arun Pratap, ex-president of RC7 IAPT, for being with us and encouraging us with his presence. Then, of course, I would also mention the name of Kavil as well as Chintan for making all this online event making happen there. Apart from that, I would also like to thank all the participants to be part of this program, all other persons who has helped us directly or indirectly in this. If I missed, please, I beg your pardon. But this event is not possible without all cooperation from them. So this is all I had to say. So on behalf of, once again, IAPT as well as APDA, I thank all and everyone for this. So thank you very much, everybody. So Kavil, I think I have delivered the vote of thanks. So you can continue with your.
Yes, sir. So thank you again, everybody, for attending this lecture. But please stay tuned. After a short break of about 2 hours, we will be having another interesting lecture by Professor Ajay Ghatak, sir. So I would like to officially end this session. And if anybody has any questions, they can ask Parmendra sir by emailing him on the email ID that he has mentioned. And okay, so we can end this session. Thank you so much, everybody. Thank you.